This is UNIFIL's Greenhill camp, covering an area of 1.2 million square metres. The mission's movement control, aviation, engineering, ICT, supply, property management, transport, and much more operate from here. 15% of the annual energy consumed in the Greenhill camp is from renewable resources. Maybe we can discuss the importance of energy production in a mission environment from your perspective.
Today, peacekeeping spends close to about 25–30% of its operational budget on fuel. We go mostly in post-conflict environment where there is very little infrastructure of national grid. So we generate our own power supply, and this generation of power supply takes about 70% of the total fuel requirement. Only 30% goes to the vehicles. So I think we cannot just stay in a traditional way and without thinking of a strategy or a long-term plan on how to get more efficient production of energy, distribution of energy, and use of energy.
This is our first solar installation. It was commissioned in 2009. It's a very efficient system with the panels tracking the path of the sun across the sky. As we began to see the production figures from this facility month after month, it became very clear to us that this was a very economically viable method for producing energy when compared to the way that we had traditionally done it.
So the way these solar panels work is that they have a small panel here that senses the intensity of the sun, and it moves accordingly. If you look at the other panels over here, solar panels here, we basically know where the sun is all the time, and it's pre-programmed, so they will just start track in the morning and finish in the evening again. Though these solar panels are more efficient, then they have moving parts such as the tracker arm here, the joints up here, and the control box here. All these parts require more maintenance, and therefore we looked for other options. So after a few years of experience with our tracking panels, we moved on to a fixed type installation here. And the advantage of this type of installation is it is cheaper, it is easier to install, and it has less maintenance. To compensate for the loss in the production compared to the tracking panels there, we simply just installed more panels. So the reason for these panels to have less maintenance if you compare to the panels over here, our tracking ones, is there's simply no moving parts. The only maintenance there is on these panels is a bit of cleaning once in a while. To give an example, all these parts is what required to maintain the tracking system. This box is the only parts that are required for the fixed system, and it's a lot cheaper as well.
Maybe we can now discuss the logistical impact of managing a fuel-based energy production system.
The first challenge is the quantity and the volume. In terms of volume, again, it constitutes about 30–40% of the total transportation need. So that is the first complexity. Second is that this material is inflammable. Therefore, its transportation becomes a little more complex than other commodities. And the third is that this commodity is required in different places throughout the area of operation. And it becomes very complex if you have to move it by a multi-nodal transportation system. Say for example, in a country like DRC, Congo, which is 3 times the size of Western Europe, delivering fuel was a big challenge for United Nations. So we were using firstly all air transported fuel and move it in helicopter with all precautions which are imposed for transportation of fuel in a helicopter. And then sometimes even from helicopter we had to transport them by 4x4 vehicles to some of the remote sites. So we were incurring a lot of cost.
One thing to consider is the distance between the solar panels and where the power is consumed. The longer the distance is, the more power you will lose. This is why we installed a static solar array right on top of this building. The entire roof of this building is covered by one solar array. Right now all the power produced is used in the building. And should there be any excess power, that flows backward out in the grid, so we don't lose any power. The other thing is we don't have any batteries in this system here, so we don't have any loss in the battery charging and discharging all the time. Based on the success of this building here, we installed our fourth array on this building down here. What we see right now is we have about 80% of the maximum capacity of the solar panels on the roof here, and that's around 23.5 kilowatts, and that's pretty much all the power we're consuming in the building, and this office here is coming from the solar panels right now. Should there be extra power from the solar panels, one thing we can do is charge one of these, and then we don't have to walk anymore.
From our experience, certain criteria are followed when doing solar installations in a peacekeeping environment. First of all, the installations should be large and static. Secondly, the installations should be dispersed. They should be dispersed around the camp and in locations close to where the energy is being used. And thirdly, the energy that's produced should be put into the mission grid and used immediately. So let's take a look at the costs of producing diesel-generated power versus the costs of producing solar energy. Both require significant initial capital investment. The raw material for diesel-generated power is expensive fuel, while the raw material for solar energy production is sunshine, which is free. With generated power, there are significant direct labour costs, whereas with solar energy, once installed, there is practically no additional labour costs required. With generated power, there are also significant indirect costs, such as inventory staff, warehousing, spare parts, procurement, etc. Whereas with solar systems, once installed, they're practically maintenance-free. Using an internationally recognised formula, the installations that you have seen will return the organisation's investment within 5 years. Once 5 years has gone, each kilowatt of power produced by these installations will effectively be free of charge. For the foreseeable future, peacekeeping missions will continue to rely heavily on fossil-based systems for their energy requirements. However, we believe that many of the missions out there who rely 100% on diesel-generated fuel can migrate to a hybrid system, with at least 25% of their energy requirements being produced from solar means.